Hello, geometry friends. This is a great movie if you haven't seen it. Trolls. Excellent. Anyway, what we're talking about today is areas of regular polygons, okay? So you have your whole formula sheet. You have another one today. Make sure that you've put that in Notability. You can pause this at any time, but go back and forth. All these formulas start to get really tricky. So we're actually only going to do one today because these can get pretty complicated, even though you can kind of see it's a pretty simple formula, simple enough looking formula. These can get pretty tricky. Okay, so first, you see this circle over here. I'm going to start over here. I'm going to put a hexagon on the inside of this circle, okay? And I want you to pretend even if it doesn't look like it, okay? Pretend like it's, so what I've done is I've drawn a hexagon inscribed in the circle, okay? And I also want you to assume that it's regular, okay? And so when we talk about a regular polygon of any number of sides, okay, that means that all the sides are the same, okay? That's what regular means. Okay, so anyway, so it's inscribed, that means also it's touching, each of these vertices is actually touching the circle. Okay, I'm going to call this circle P, okay? I'm going to extend a line from P to M, okay? I'm going to extend a line over here from P to, I'll call that point N, okay? And then I'm going to do a bisector here that's perpendicular. Okay, I'm going to call that point right there the point Q, okay? And so that's bisecting one of the sides from the center. Okay, so a couple of things. First of all, PN, okay, from P to N is, of course, a radius, okay? The measure of angle MPN, so M to P to N, so this whole angle right here is a central angle, okay? And then also we have a new term here, from P to Q, okay? So that line that goes from the center to the middle of one of the sides, that's what we call the apothem, okay? Some people pronounce it differently. I call it the apothem. You might hear it pronounced differently on other videos if you check. Okay, but that's the shortest distance from the center to the middle of one of the other sides. Okay, so here's our formula. The area, okay, so to cover any polygon, okay, so any number of sides, that's what n represents, where each side is the same length, will be always half of the product of the apothem times the perimeter. Okay, and so actually I'm going to also share with you today something that you didn't know about your math teacher, but you can take a look at this problem. It's a table, so let's just say that we are going to tile this table, okay? We're going to lay tile just across the top of it. So how much tile would we need? What's the surface area? So what you didn't know about me is that I actually love to tile, and so this is actually a practical application to me. So I will share with you, for example, a table that I just tiled a couple of months back, okay? And this is really important. It's really important to know what surface you need to cover, what the area is, because for me, like these big guys right here, these big beautiful tiles, well, I think they're beautiful, but they cost like $15 a pop. So you don't want to be, ordering too many, right? You want to order exactly the right amount because, right, otherwise your simple job gets a little bit expensive. Okay, so here we are. First little example here. Let's pretend like we have this, looks like it's an octagonal table. It's got 8 sides, okay? And we want to figure out what the surface area is. How much space do we need to cover? Okay, so you can see from the center to one of the vertices is 19.6 inches. We've measured that with a measurement, okay, with a measuring tape. And then each side is 15, okay? So let's just think this over for a second. Okay, let me kind of start to draw this for us. Okay, so we have an octagon. okay? Pretend like all the sides are the same, okay? And then again, what I'm telling you is that from here to here is 19.6, okay? And each one of these sides, the sides are all the same because it's regular. Each one of those sides is 15, okay? And so you'll want to have a calculator handy too also, by the way. But if you just kind of check this out here, we know that the area formula is going to be a half of the apothem times the perimeter. Okay, and so I'm just going to first draw in the apothem from the center to the middle of one of the sides, okay? So that would be what the apothem is. Okay, now the apothem, it's always going to bisect the sides, okay? So if this whole thing is 15, then that means that just from the apothem to the edge right there has got to be 7.5, right? It's the 15 cut equally into two pieces, okay? So now I just want to highlight this triangle right here, right? See that little triangle, that right triangle that we formed there? Okay, let me just redraw it for a second. Okay, so here it is. Okay, and that question mark, of course, would be what the apothem is, right? And hopefully you're already thinking Pythagorean theorem, right? Okay, so if we do this side squared, which I'll call A, okay, plus the 7.5 squared, that should equal the hypotenuse squared, okay? And so we'll just do that math for just a second. So let's see, we have 7.5 squared, and I think you'll get 56.25, okay? And then 19.6 squared, I got 384.16, okay? We'll then go ahead and subtract the 56.25, so we have the 384.16, and we're going to subtract from it the 56.25. And I think we get 327.91. Okay, and then of course if we square root both sides, okay, so the square root of the 327.91, okay, I get 18.1028235965, okay, and that is the apothem, okay. And so now I think we're kind of ready to go ahead and start plugging into the formula. So we have A, the area that we're going to need to cover, is going to be a half of the apothem, which is that 18.108. I'll go to maybe 5 decimal places. And then times the perimeter, which can we all figure out, remember what perimeter is, right? It's going to be 15 8 times, right? And so the perimeter is 15 plus 15 plus 15 again, 8 times. I think, right, 15 8 times is going to be 120, okay? And so last step, this is just a multiplication now. It's 0.5 times the 18.1 times 120. And so when we do that, we will get 1,086, I'll just go to 1 decimal place, 0.5 inches squared, square inches. Alrighty, okay, so maybe that one didn't seem too tremendously difficult, but here's one that is a little more challenging. So let's move on to our we problem, and let's just really, like I said, pause this if you need to, just to kind of think it over. But here's our we problem. So we have a regular nonagon, and it's inscribed in a circle with a radius of 4. So what has got to be the area of that nonagon? Alrighty. Okay, so let's just take a look here. We've got a nonagon. Remember, that's 9 sides. Now, I'm not very good at drawing when it's like more than 4, so bear with me here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so just pretend, okay, like this is perfectly fitting on the inside. Okay, this perfect nonagon. Okay, and now what they're telling us is that only the radius from the center to one of the vertices is 4, and that's all we know, okay? And from that information, we want to figure out what the area of this 9-sided figure is. Okay, so let's just think, I'm just going to draw where the apothem would have to be. Okay, the apothem would be here, okay? And so what we're going to need to do, we have A equals a half of the apothem times the perimeter, okay? So first, I think I'm going to go after the apothem, okay, which is of course this purple line here, okay? And we need to just kind of think about the central angle. So let me draw this line as well. Okay, so it's a 9-sided figure. Let me just go ahead and draw in all the slices. Think to yourself, how many degrees to go all the way around a circle? Good, 360, right? Okay, so if we have 9 slices to go all the way around a circle, 360 divided by 9 means each of these central angles has got to be 40, right? 40 all the way around, including this slice, right? This slice right here. And then it's cut in half, which means this is 20, and so is this. Okay, now if we're trying to first go after the apothem, which is right here, the purple line, okay, you want to think about your trig ratios, okay? The sine, the cosine, and the tangent. Okay, so if we're trying to solve for this and we know the hypotenuse, with respect to the 20, don't you agree that the apothem is going to be the adjacent side to it, and the 4 is the hypotenuse? We're going to want to use the cosine, okay? So the cosine of 20 degrees will equal, I'm going to call it A, this side right here because it's the apothem. The apothem, the adjacent side also, over the hypotenuse, which in this little triangle right here is 4, okay? And so if we cross multiply and solve, we're going to get 4 times the cosine of 20 degrees, okay? And 4 times the cosine of 20 degrees, okay? Where did I punch this out? I didn't, of course. 4 times the cosine, let me just do it real quick on my calculator. 4 times, make sure I'm in degree mode. Okay, 4 times, let's see, the cosine of 20, okay, and I'm getting that the apothem is about 3.75877, okay, and some change. Okay, there's our apothem. Okay, now we want to go after the perimeter. Okay, so we're going to need to find out this whole side, but first I'm just going to find from here to here. Okay, what?
Oh, I have to take this.
Okay, just a second. I just want to find from here to here, okay? So, go on. Okay, so with respect to the 20, to just find from here to here, that's going to be the side opposite from the 20, okay? And so, go. So we're going to use the sine ratio, okay? So the sine of 20 degrees is going to equal opposite, which I'll call x for now, over the hypotenuse, which is 4. And if we cross multiply and solve, we're going to get that x, which is just that piece right there, is 4 times the sine of 20 degrees, okay? And so 4 times the sine of 20 degrees, okay, is about 1.36808 and some change. Okay, so now remember 2 times that is going to be what the length of this whole side is, okay? So if we next just take that and times it by 2, okay, that means this length of just this side is 2.73 roughly, okay? Now remember there was 9 sides, okay? So 2.73, when we times that by 9, okay, we're going to get that the perimeter is about 24.62, okay? And so lastly, let's just go ahead and do our calculation here. We're going to get 1/2 times the apothem, which was 3.75, times the perimeter, which is 24.62. And when we do that, we will get, or you should be getting roughly, that the whole thing is about 46.3, and I didn't put any units here, I don't think, so just units squared. Okay? All right, so let's take a look. Pause it if you need to. Come back to it if you need to. I know it's a lot for today. Be sure you're using that note sheet. Okay, so last one. Okay, so we want to find the area of a regular pentagon. And I'm telling you from the center to one of the vertices is that, and that the apothem is 6.5. So give it a shot. See if you can figure that out. Okay, and if you've done it correctly, pause it if you need to before you try, but I think you should be getting this. Okay? Okay, so have a good day. Practice.
Bye.
All right.
Bye.